Alright, you guys will need a calculator today and a textbook and a fresh sheet of paper, so if you want to get all that sorted out. Okay, so we are moving into our last section of logarithms, section 3.4, which is where we focus on solving logarithms, solving equations with logarithms, or solving exponential equations. So our notes here are slightly more important than normal, I think, because it does try to show you all the different strategies. There's a handful of them that you need to know and consider on any particular question. And then you guys can see that there's a really long book assignment that goes along with this, but we won't get finished with it today, and that's okay. But we should get the majority of that done, like 60% or so, especially since the first few questions are pretty quick. All right, so logarithms are great for solving real-world type stuff. They're certainly going to shine for you in your science type courses, but realistically in mathematics, most of the reasons we learn those log properties are so that we can solve equations like the ones on this sheet. It's really all been kind of building up to this for us. So the whole point of logarithms and what makes them so special is that it will solve exponential equations. So anytime you have a variable in the exponent, an exponential equation, if you wanted to solve for one of those variables, you would have to know your log properties. Now, on this handout, I got it kind of organized from what I think is fairly the easier stuff and then kind of builds up to the harder stuff. So make sure that you're sticking with us here. So the first thing you should consider is you don't always need to use log properties. Depending on the question, if the question's easy enough, you don't have to do log stuff and log properties. So like question 2, 5 to what power gives you 25? Hope that you could just do that in your head. 2 to the 4th is what gives you 16. Those are nice whole number answers. I don't need to do anything fancy here. Even if it's a logarithm, as long as you know how to read it, this is saying 2 to what power gives you 8, and 3 to what power gives you 9. If that's something that we can do in our head, then obviously we don't want to overcomplicate it. So we got a few of those in the book assignment. So that's usually the first thing I check for. The next thing I check for is, and this is the biggest one, is switching forms. Either switching from exponential form to logarithmic form or logarithmic form to exponential form. So if you had this equation and we're solving for a variable in the exponent, you could switch it from its current form to logarithmic form. Remember logarithmic form, you put log out front and then these two switch places. And then if you have x equals, then it's solved. Personally, I prefer to rewrite that as natural log, but okay, this is in exponential form. If I switched it to logarithmic form, it would be solved. Exponential form, switching it to logarithmic form gives me x equals, so it is solved. So sometimes just switching the form is all that needs to be done. So that's one of the, if it's not something I can do in my head, that's the next thing that I would consider. Now, the exact same questions over to the right, this is probably the least used method. I want you to see that we get the same answers here. Probably the least used method, but there are some questions where this is necessary. So we're gonna go over this one. You're gonna forget about this as a possibility, and then that's gonna create some of your homework questions. So same thing, instead of switching the forms, sometimes what you want to do is take the log of both sides. Now, if I take the natural log of one side, I take the natural log of the other side. If you'd rather use a normal log, that's okay too, or a common log. Just because this is base, or E, and natural log is base E, that's why I chose to do that. And now, if you take this route, your question's going to finish a little bit different. Now your exponent is on something that you're taking the log of, so the exponent can come down out front. You need to know that the natural log of E is 1, because it's saying E to what power gives you E. And notice, same answer, different approach. Honestly, when it's up to me, if it doesn't matter, I just switch the forms. I think what we're doing on the left is quicker and easier. But again, there will be some questions where this is your only strategy to move forward. Okay, so number 10, we'll take the log of both sides. I'm going to take the common log here just because this is a 10. You could take the natural log if you would prefer. But this is okay to do because I did it to both sides. Now x is an exponent on something that I'm taking the log of, so that can come down out front. Log base 10 of 10 is 1 because 10 to the first gives you 10. So we get log of 3. Same thing as over here. Okay, and then one more. If we took the log of both sides here, and then bring the x down, and then undo times with divide, same thing. You just need to know that when nothing else works, none of the other strategies we talk about, sometimes this is necessary. If it's optional and you think it's easier, then do it. But if you can't think of anything else that'll work, sometimes taking the log of both sides is what you need to do to move forward. Now notice, this answer looks slightly different than the one over to the left, but if you know change of base, then you know these are the same. This is, if you applied change of base to this, it would look like this. So, all right, so we had a couple that we could do in our head. We had a couple that we switched from exponential form to logarithmic form. And then the same questions, we saw that taking the log or the natural log, whatever you prefer, of both sides is also okay. Okay, well, switching from exponential form to logarithmic form often works, but going the other way is another good strategy. So if it's in logarithmic form, you might consider switching it back to exponential form. And if that gets you x equals, then that's a great strategy to use. Natural log means log base e. Switch the forms, and it's solved. Switch the forms, and it's basically solved. You have to do one more step, I guess. Switch the forms, and it's solved. So, switching the forms, whether you start with exponential form or logarithmic form, are certainly the most useful techniques. Those question types are very quick if you have that the top of your brain is something to consider. So consider switching the forms, consider taking the log of both sides, and consider just doing it in your head if it's basic enough. Okay, so now we're going to inch out to the ones that are going to take a little bit more work. So these are either in exponential form, 17 and 18, or logarithmic form, 16 or 19. But if you can do what we just did on the last couple sections, then you can do these as well. If it's in logarithmic form, you could put it in exponential form, exponential form, could switch to logarithmic form, exponential form, to logarithmic form to exponential form. The difference between these questions and the sections above is that these are not quite finished because these are not what x equals. They have a little bit more work to be done. You have some arithmetic to undo, or some basic algebra, whatever you want to call it. This one you would need to add 1 and divide 2 before you finished. This one you need to divide 3 before you're finished. This one you need to multiply both sides by a negative before you're finished. And this one you need to subtract 7 before you're finished. So sometimes switching the forms is a good start, but you may still need to undo add, subtract, multiply, or divide. And those are all showing up at the end of the question. So we did that to finish the question, but just as likely, you might need to undo some add, subtract, multiply, or divide at the beginning of the question before you can switch forms. So as much as you may want to switch the forms for 20, 21, 22, or 23, they're just not set up in their right format yet. But if you subtract 9 from both sides, then it is in the right format, the switch. If you divide both sides by 2, then it is in the right format, the switch. Undo a +5 with the -5, and then switch the forms. Undo a ×7 with the divide 7, 10 to the first equals 8, and then switch the forms. So you might need to undo some add, subtract, multiply, or divide at the beginning of the question or at the end of the question, or maybe even both. So that's what's happening with 24 and 25. This is how I said I was going to try to walk you out slowly to the harder questions. So if it's not set up correctly, you've got to undo that add, subtract, multiply, or divide. In this case, that would be undo times 2. In this case, this would be undo times 4. 40, 20. Then once it looks a certain way, you can switch its form. It was an exponential, so I wrote it in logarithmic. This one's also an exponential, so I will write it in logarithmic. And then if there's still some arithmetic or basic algebra to be undone, then I need to do that before I give my answer. Looks like this one, divide both sides by 3. This one, divide both sides by 5. So always undo your add, subtract, multiply, or divide before you try to switch the forms. If it's not set up in the right format to be switched, then you've got to do that first. And then on some of the harder questions, even after you switch the forms, you might still have to undo some add, subtract, multiply, or divide. Okay, I think that's the end of the front page. Any immediate questions y'all see yet? Okay, let's keep going. Okay, so in section 3.3, last time I saw you guys, we focused just on expanding and condensing, and I'm sure our next test, which unfortunately we will not get to before spring break, so that means when we come back from spring break, we'll probably review the first day back and then do the second test. So I don't know if that's good or bad, but that's just the way it's going to fall. But I'm sure our test will have a couple questions just seeing if you can expand or condense. But really in mathematics, the reason we want to do this is so that we can solve more equations. So in 26, if you try to solve this in any of the methods from the front page, none of those are going to work. This is not basic enough for me to do in my head. It's not set up to be switched forms. There's no add, subtract, multiply, or divide that I can do. You pretty much hit a wall pretty quickly. Unless you say, well, wait, I can shove these together into one logarithm. Addition condenses into multiplication. And then all of a sudden it does look like what we were doing on the other side. Now you can switch forms and solve for x. But if you don't consider expanding or condensing, sometimes you're going to get stuck. So that was one way to condense. The only other way to condense that we learned in 3.3 was with subtraction. If they were separated with subtraction, it will condense as division. That makes it look like the right format. Now we can switch it from logarithmic form to exponential form and multiply both sides by 3. And then you can stop there. I don't expect you to know what 7 to the 7th is without a calculator. Okay, one more example. I'm not sure why 29's there. That doesn't fit this type. As much as you may try anything else, none of the other stuff on the front page is going to work. At some point, you got to say, all right, one thing I could try to do is condense these. Addition condenses into multiplication. Then you could switch the forms, and then you can undo the arithmetic. Now this one, as well as several others, you guys should notice a lot of times your answers here look pretty unfamiliar. Most of the time if you worked a math question and you got an answer that looked something crazy like this, you would just assume that you did something wrong, because a lot of times, especially in lower mathematics, questions are just worked out, are rigged to have nice whole answers or occasionally some fractions. But they don't have to be. So we're going to talk about how to check this before we're done with the notes. Okay, back in section 3.2, we did solve a couple equation types, so this is certainly not going to be the highlight in section 3.4, but this stuff would still be fair game. So this is like if we had log base 2 on this side and log base 2 on this side, that's already equal. We just make sure that the insides are equal. And then you need to plug it in to make sure that it's not extraneous. Or maybe one of our log properties makes this simplify and leaves us something that we can then do in our head. So I'm not focusing on those, but you'll have a couple of those question types sprinkled in, but we did those in 3.2. All right, and then finally the last of the unique types that you should see would be these question types where you end up with 1, 2, 3 different terms. So again, it's fine to go through the list of things to try. In fact, I have them all typed up for you on the bottom there. But I can't do that in my head. I can't switch the forms. There's no basic algebra to be undone. I can't expand or condense. None of the other techniques we talked about worked. So on this type, you need to know the way to move forward with this when you see one that looks like that is factoring. So if you need to slow down and do product sum, then please do. But e to the x times e to the x is how you're going to get e to the 2x. You need a minus 4 and a minus 1 to get you a positive 4. And so the outer and inner part of your FOIL combines to give you minus 5 e to the x. You do not have to factor with guess and check, and you don't have to do it as quickly as I did. But you do have to be able to factor it correctly. Then just like any other quadratic that you did this on, if this times this equals 0, you should set this equal to 0 and solve, this equal to 0 and solve. This one you need to switch the forms before you get your answer. This one you need to switch the forms before you get your answer. But natural log of 1 simplifies. So the main thing I need you to get out of that example is when you see a question that looks like that and nothing else works, you need to try to factor it. That's really the only way to move forward. Okay, I want to show you one real life example with question 32 so you can see why we care to be able to do this before we dive into the practice. and remind you how to check your answers, especially for the answers that look more complicated than you're used to seeing. And then on the bottom of the page, I have all of these strategies typed up, all the stuff that we just did on this handout. So that's kind of how you need to format your thinking. Then we'll move on to the book practice. Okay, so in section 3.2, we talked about this compound continuously formula. And we may have told you, like, you've got $2,000 to invest. You go to the bank, they give you a percent. You type that in as a decimal. But in section 3.2, when we introduced this to you, we would tell you how long the time was. So you would put a number in for t. And then maybe you threw this in the calculator to get a final answer, to get the amount. Or you just pick the multiple choice selection. What's different is now we can say we don't know the time, but we want to wait until this grows to 6,000. This is more realistic to how you would want to do things in real life. You've got some money, you know what you're saving up for, and this would allow you to solve for the exact amount of time. Now in this example, you may not care to have it quite as precise. If you were trying to save up for a car, you know, just being within a month or two is probably plenty fine. But if you guys get a job someday with a math or science degree and somebody hires you and, you know, they're a business and they're trying to be as efficient as possible, they need you to be able to be very precise and not just kind of close. So this is what we can now solve. This is what we did on this worksheet. If there's any basic algebra to be undone, like undoing times, we can do that. You don't have to switch these two, but I think it helps you see that this is an exponential form, and this is what it would look like in logarithmic form. And then finally, just because you switch the forms doesn't mean you're done. You might still need to do undo, add, subtract, multiply, or divide. In this case, undo times. And then there's the exact amount of time. So if you put $2,000 in the bank, they only offer you 2%, and you're going to leave it alone until it's $6,000 for whatever you're saving for, car, whatever. That's the exact amount of time. And we could type that in our calculator if we wanted a decimal. It's about 55 years. So if that was your plan for your first car, you would probably want to come up with a new plan, because you're not going to want to wait 55 years. You want to add some more money to that or something. But that's what logarithms can do. When a variable is in the exponent and we want to solve for it, logarithms are the only way to get it out of the exponent and solve with our other algebra skills. Now, when you get an answer like this, again, this is an unfamiliar looking answer. It's not a nice whole number. Most of the time our answers look crazy like this. We're used to this being wrong. And I will tell you, in the book assignment, you may make your answer look a little bit different than the back of the book or how I do it on the solution videos, but your answer can still be okay. Sometimes it just depends. Like up here on the front page, when I took the log of both sides, if I took the log of both sides instead of the natural log of both sides, my answer is going to look different. Or if I had done the natural log of both sides instead of the log of both sides, my answer would look different. So you need to have a way to check your answers and not just assume that everything is incorrect. So that is with storing in your calculator. So I know I've showed this to you a lot of times, but if you type in what you think the answer is, so I'm just using our last question as an example. This button right above the on button is the store button, and you can store that in for any letter. Now I usually store it in for X because X has its own little button here and it's just convenient to use. But we did just solve for time, so you might want to do alpha 4 to store it in for T. You can store it in for any variable you want to. Then, if this is really the answer, your calculator keeps up with this exact amount. It doesn't just round the decimal. You can plug it in to see if it really works. it's supposed to make 2000 e to the 0.02 times t. It's supposed to make this equal what?
6,000.
So if you type that in and you get something other than 6,000, then your answer is wrong. If you type it in and your answer looks different than the back of the book, or different than what maybe I did, but you get 6,000, then it's still fine. So it's very important that you check your answers in these. Now, if you work a question and your answer matches up with the back of the book, then that's fine. You don't have to also check in the calculator. I just want you to know that sometimes your answers are still fine. So make sure that you're aware of that store button and practice using it. I honestly think that's one of the stronger things your calculator can do. Very, very good for the ACT too. Like sometimes when I see those multiple choice ACT questions, not that I do a lot of them, but sometimes it's quicker to just store answer A in and then check to see if it solves it. And if it doesn't, store answer B in, plug it into the equation, see if it solves it. Sometimes that's faster than actually working out the question, even if you know how to do it. So I think that's a good skill to practice. All right, and then all this is just typed up. This is the stuff in the order that we did from the first, starting from can we just do this in our head, all the way down to the factoring questions, checking for extraneous, and checking in the calculator. Okay, so on your piece of paper you guys got out, if you go ahead and copy down the full assignment, and the first several questions are definitely much quicker. They're not multi-step questions. They're usually one step or two for a while. So go ahead and copy that down and start the first few, see how it goes. And then once I think you've had enough time to do about the first 7 questions, I will interrupt you and help out. And again, I do not expect you to finish this book assignment today. Again, the first few questions, the first half, first 60% of the assignment shouldn't be too time consuming. But when you get near the end, you're going to get questions that take more steps. So I don't expect you to finish this in class. I don't even expect you to finish it for homework between now and Wednesday. But I will expect you to do it this week. So the more that you get done in class today will be that much less on Wednesday. Or intern Friday. But Okay, so with the first few questions, one, any part of one, question two, checking your answers in question three, starting to solve some basic equations in 7, 8, 9, and 10. So any questions you guys have yet from 1 through 10? Okay, I'll give you some more time to keep going then. Especially these questions at the first. If you get stuck, don't spend more than a minute or two. Just at that point, skip it and then ask about it when I take questions. All of these first ones should be fairly quick, so if you're not seeing what to do, just move on. Now, I know I've recommended this in the past, but as you guys work through your assignment, please consider circling the ones that you missed the first time, or making yourself notes on what you didn't consider to do. Since this part of the test won't fall until after spring break, you guys are going to have that whole week off. You're not going to think about this at all. We'll come back and have that one review day, and it would be very beneficial to yourself if you could then look at your homework here and just go straight to the questions you missed the first time and have written out some hints on what you didn't do right or what you didn't consider. Doesn't seem like that would be important right now, but I bet it will be after spring break, so please consider doing that as you guys move along here. let me give you another chance to ask here, maybe over the first like 15 or so. So anything from number 1 in the textbook up through number 20, if you've made it that far yet.
17.
Number 17. Alright, 17 is saying approximate the point of intersections of the graph of f and g. So one of the equations is 2 to the x and one of them is 8, y equals 8. So for part A, they just want you to approximate what you think the answer is from the graph. So that would be when they are at the same place in time, when x equals 3. And then for the second half of the question, verify it algebraically. So when does 2x equals 8? That would be when x equals 3. So they just want you to see what your answer would look like visually. Okay, another one up through question 20. Okay, I'll give you some more time then.
Can you actually do question 20?
Sure. Now, if you've not made it to question 20 yet, that is understandable, but you may want to jump ahead. I do have most of these worked out, so I guess you could watch it on the website later, but since you'll probably get to it in a few minutes anyway, you may want to jump ahead. Alright, with question 20, what I noticed about this one is that this side has a base e and this side has a base e, so this stuff's already equal. I just need to make sure that the exponents are also equal. E to some number, as long as it's e to the same number, then those would be equal. So you need to make sure that the exponents are equal to each other. Because this is a quadratic, you must put everything on one side equal to 0. Now, this isn't going to happen all the time, but I think it does happen like twice here in this assignment, 2 or 3 times. You're used to factoring. The problem is factoring doesn't always work. If factoring doesn't work, the only way for you to solve a quadratic would be with quadratic formula, which of course is not my preference either, but if you plug in -1 for b, -1 for b again, 1 for a, -1 for c, and 2 for a again, then a little bit of arithmetic, you get your 2 answers. So, 3 things to that problem. One is understanding the setup. If this side was already e to some power and this side was e to some power, you just need to make sure that the powers are equal. You need to remember to solve a quadratic. Everything has to be on one side equal to each other. And if the quadratic doesn't factor, your only option is quadratic formula. So, obviously I would try to avoid that, but you will need that at least once more today. Okay, let me reset my timer here, let you get a few more questions under your belt. But same thing, as you guys get to one, after a minute or two, just move on from it. Don't spend too long on any one question. And as you get to answers that don't match up in the back of the book, if you don't see what's wrong, try storing your answer in the calculator to check. All right. Have y'all found any that you'd like me to help out with? Okay. Alright. Any questions y'all found I can help with?
38.
38. Now, as you get further along in the assignment like this, again, I just kind of think of the notes and how it's structured as to what I would consider doing. I certainly can't do this in my head. This does not fit one of the forms that I can switch. I can't undo these addings yet because they're in the exponent, so I can't undo any basic algebra yet. There's no logarithms to expand or condense. It doesn't look like the factoring type of question. So if you exhaust all of those things, one of the few other things on your notes was the one that I said you would need sometimes is you need to take the log of both sides. The log or the natural log of both sides, doesn't matter. That's the only way to move forward on question 38. Now, this stuff is an exponent on a log, so that can come down out front, but the natural log of b is just 1. This stuff can come down because it's an exponent on the log. And then natural log of 2 is just a number, so I'll distribute that. Okay. And then just like if anytime you're solving for x, anything with an x on it needs to go to one side. Anything that's a constant needs to move over to the other side. And then you need one more little algebra trick to finish this. Most of the time, you guys are used to these being like terms, but in a way that you can combine them. If this was 8x minus 3x, you could quickly say 5x. But this is 1x minus the natural log of 2x. You don't know how to combine those. But what you can do is factor out a GCF, and then finally undo times with divide. So most important there is that step 1. If you never consider taking the log of both sides, there will be a few questions that you just can't do. But I did that so I could bring the exponents down. Most of the rest of the solving was pretty straightforward, except maybe this right here. I know you can all do GCF, but you also got to be able to see when to do it. And then finally, just to practice what I'm preaching here, that is a very unusual looking answer. So most of the time that would mean we went down a wrong path somewhere. I'm going to assume that the answer in the back of the book looks different, although it may look the same. But it does not take you very long to store that in your calculator, like I just did while I was talking. And then make sure that the left side of the equation is equal to the right side of the equation. I don't care what it equals, as long as the left and the right are equal. And the fact that the left and the right are equal tells me that even though this answer looks pretty complicated, may not look the same as the back of the book, it is perfectly fine.
Will we have calculators on this next test?
Probably not. It would be nice for the checking part, but short of that, it doesn't do much for you anyway. Okay, anybody else have a follow-up to number 38 while it's up there? Because I think this is one of the harder ones with that first step. Okay, I will check back in one more time. You guys still have about 17 minutes. So again, just to be clear, you do not need to have this finished by Wednesday, but I will ask you to finish it on Wednesday. So less you have to do, the easier that'll be. So don't give up yet. one more check-in before we're out of time for today. Any others that you've tried that you want some assistance on?
46.
Number 46. 46 actually looks a lot like one of those compound interest formulas, not the print one, but the other one. Looks like that has been set up, but you are trying to solve for t here. Now, even though this is a big mess, it's actually still one of the steps on our notes here. This is exponential form, and logarithmic form would have me switch these two, and then all of this would become the base. And then undo times 12 with divide 12. And it's kind of ugly, but it should be fine. But of course, makes sense to go ahead and test it out. Okay, so I stored all of that in my calculator for t, and that's supposed to make 1 plus 0.10 over 12 to the 12t. It's supposed to make it equal 2, and it did. So now I know for sure that that answer I got was correct. So, more stuff to it, but big picture was still just switching from logarithmic or exponential form to logarithmic form, and then undo times 12 with divide 12. But you have to kind of get over the fact of how messy it looks. Okay, I would say we got just about 4 minutes here, so y'all need to find a stop in place. I'd say if you didn't at least get to around question 34, 36, around there, you probably should do a couple of those for homework between now and Wednesday to help yourself catch up to everybody else. So I've got a one-page worksheet that I will ask you to do on Wednesday to review some 3.3 and some of this 3.4, and then I'll give you some time to finish up the rest of it. But of course, the last questions might be longer and more time consuming, so you need to be more than halfway finished with this.